Welcome to this comprehensive tutorial on the factory game design pattern, a fundamental concept for beginner game developers. The factory design pattern is a creational pattern that provides an interface for creating objects within a superclass, allowing subclasses to alter the type of objects produced. It encapsulates object creation, making your code more flexible, scalable, and significantly easier to maintain. Instead of directly instantiating objects with a new keyword, the factory pattern delegates this responsibility to a separate entity, the factory itself. This approach significantly reduces coupling between your client code and the concrete classes, leading to a more robust system. Let's explore the key concepts that form the foundation of the factory pattern, starting with the product. The product defines the interface for objects that the factory method will create, establishing a common contract. A concrete product then implements this product interface, representing the actual objects that are being created. The creator declares the factory method, which is responsible for returning an object of the product type. Finally, the concrete creator overrides this factory method to return a specific instance of a concrete product. Now, let's differentiate between the various types of factory patterns you might encounter in game development. The simple factory, while not a formal design pattern, is a common programming idiom using a static method to create instances based on input parameters. It offers a centralized point for object creation, making it easy to manage, though it's less extensible than other factory types. The factory method pattern moves the responsibility of object creation to subclasses, defining an abstract method in a base class that concrete subclasses implement. This allows for greater flexibility, as new product types can be introduced without altering existing client code. The abstract factory pattern lets you produce families of related objects without specifying their concrete classes, often used with the factory method. Understanding the benefits of the factory pattern highlights why it's a valuable tool in your game development arsenal. One major advantage is decoupling, which reduces the dependency between client code and concrete classes. This means your client code interacts with an interface or abstract class, not specific implementations. Flexibility is another key benefit, making it easier to introduce new types of objects without modifying existing code. Adding new product types doesn't require changes to existing ones or modifications of previous code, saving development time. The pattern also enhances scalability, allowing you to easily extend your system by adding new factory types without altering existing code. Maintainability improves as object creation logic is centralized, making the codebase simpler to manage and understand. Code reusability is a natural outcome, as common object creation code resides in one place, preventing duplication. Finally, it provides abstraction between implementation and client classes through inheritance, simplifying complex systems. Knowing when to apply the factory pattern is crucial for effective game development. Use it when you don't know the exact types and dependencies of objects your code needs to work with beforehand. It's ideal when a class has general processing logic, but the specific subclass can only be determined at runtime. Also, consider it when you want to provide users of your library or framework a way to extend its internal components. It's particularly useful in systems requiring dynamic object creation, such as spawning different types of game characters or items. Now, let's dive into a practical implementation of the factory pattern in Unity with C#, using an enemy creation example. First, we define a product interface, iEnemy, which outlines common methods like spawn, attack, and die that all enemies must implement. Next, we create concrete products, such as orc and troll, which implement the iEnemy interface with their specific behaviors. Then, we define a creator interface, iEnemy factory, which declares the createEnemy factory method. Following this, we implement a concrete factory, enemy factory, which is responsible for creating specific enemy types based on input. Finally, our client code, typically a game controller in Unity, uses this factory to create enemies without needing to know their concrete classes. This approach allows you to easily add new enemy types, like a dragon, without modifying the existing game controller class. Let's see this in action within Unity 3D, demonstrating how different enemies can be spawned dynamically. Observe how the game dynamically creates and manages these diverse enemy types, showcasing the pattern's power. In summary, the The factory design pattern is an indispensable tool for creating flexible, scalable, and maintainable game code. By centralizing object creation and reducing coupling, you can build more robust and adaptable game systems. We encourage you to experiment with this pattern in your own projects to truly grasp its potential. Thank you for watching this tutorial. Happy coding and game developing!